electrical engineering, it is essential that you understand the concept of resistance. If you don't understand the concept of resistance, you're not going to get anywhere in the field. The whole entire idea of electrical engineering comes around the idea of resistance and Ohm's law. Those are two essential things to understand. If you don't understand resistance, voltage, and amperage, you're not going to get anywhere. Those are the first basics that you need to learn in order to start a career path as an electrical engineer or any major that involves electricity. Even electricians sometimes need to know and understand Ohm's law, because there comes later things like power factor, which if you don't know and understand resistance, you're not going to understand that yet. But you will need to know what resistance is, and it will pop up plenty of times in your career path, even if you don't go to college. In this video, I'm going to show you guys a little bit of examples that I created that might help you understand resistance in a more thorough way compared to some other videos on YouTube or even lecture. These notes that I made are just directly from me. I didn't get these from anywhere else. They're related to what I've learned and what I understand, but these concepts kind of aren't directly from the course material. This is stuff that I creatively kind of made and am going to explain a little better here in a minute. So this video is understanding resistance by a second-year electrical engineering student, because I'm a second-year electrical engineering student. So what I want to do first is have you guys imagine this right here as being a protrusion out of a wall where we just have some sort of outlet with water being able to flow through, and then a hose connected to that. So just like your hose outside your house. And what I'm going to start off by doing is explaining what the hose is actually doing in physical terms. We have a higher potential of energy at the start of the faucet, or whatever you want to call it, and then at the end we have a way lower potential energy. So what we see here is that there's a potential difference in energy between the start of the hose and the end of the hose, and that's why we have water flowing through it. It's like the same as letting a ball roll down a hill with a different slope. You have a greater potential energy if you have a perfectly 90-degree slope, and if you have a more of a 180-degree slope, you're not going to have any potential energy. The same thing with pressure, and then that also relates directly to electricity. Let's say we have a voltage source Vn right here. It can be DC or AC. There's two different types of ways to produce and distribute power, and one of them is DC, one of them is AC. I'll talk about that later if you guys don't understand it, but that'll be a different video. The first thing is Vn is going to have a high voltage and current. It's going to have power attached to it. It'll be a battery, whatever it is. And so that's what gives the higher potential to this end, while the other end would be your whatever you're connecting it to. It has no power in it. There's no energy already in it. Energy wants to go from high potential to low potential, so that's why when we have that energy stored in a battery, it gets flown into your output, whatever you want to be charged, whatever you want to use. That's the concept right there. But we also have something called current, which is basically the flow of electricity within the hose. So the pressure would be the voltage, and the current is going to be the flow rate. So how fast is this flowing through here? And then you can also think of resistance as being basically how wide is that hose. If it's wider, you're going to have way less resistance, way less constriction. But if it's smaller in diameter, just like it is there, you're going to have more resistance when this is smaller. So basically, we have high potential, low potential, and the potential difference is equal to the voltage. Okay. And the reason of that is because you could have, the reason we say potential difference is because this could have a voltage over here. This could be not a ground. This could be another source. So whatever source has more potential in it is going to flow towards one with less potential. So that's why we say potential difference, because there's a difference between each of these. And that difference is what determines the flow of your electrons in the wire. And the flow of electricity also has a direction. It can't, AC, we can talk about this. AC would be going back and forth in direction, while DC is going in one direction. So, but the current is always at one time only going in one direction. It's never at one time going in both directions. That wouldn't make any sense. So, yeah. We have another point here is that the wire wants to be neutral. So that's why we have this flow of electricity as well. It's because the wire wants to maintain the same amount of electrons on each area of that wire as it can. It distributes them evenly. So it flows through it to even it out. So now I want to just talk about the idea of resistance, resistors, and Ohm's law. Ohm's law is a set of equations derived based on the principles of electricity. And what we have is voltage is equal to the current times the resistance. The resistance is equal to the voltage over the current. The current is equal to the voltage over the resistance. These two are derived from this. If you can't see that, it's basically just voltage over current. So you divide this out, and then you get the resistance here. Do the same thing for the resistor. Voltage over the resistance is equal to I. So if you just remember this, you will be perfectly fine. V is equal to IR, and then derive the other ones when you need it. So, resistance. Once again, it's the opposition to the flow of electrons. So, we have a resistor which we implement into a circuit to reduce power, reduce current, or reduce voltage. And you can get these things depending on your configuration of the circuit. So this right here, if we were to consider this as like a connection or a node, and then this connection as a node, let's say that we connect a battery source to here. So let's just say positive, negative. The flow of electrons is going to go from the positive to the negative based off of the current. It flows from higher potential to negative potential. Just imagine it as that for now. And we have a current 1 that flows through this resistor, and then a current 2 that flows out of it. For a resistor in series, which this is in series, it's going straight to the positive to the negative connection, we would have the current stay the same. However, we would have a difference in voltage. So the potential difference across this wire right here would be different from the potential difference across this wire right here. Also, the reason for this is because the resistance in series is going to induce a voltage drop. So the current will stay the same, but the voltage will drop because of this resistor. And if we come back over here to Ohm's law, we can get this from V is equal to IR. But the voltage drop across the resistor is equal to the current times the resistance. current going in times the resistance, is equal to the voltage drop of that resistor. So what we could do is we could take the voltage here, V1, subtract the drop in voltage from this resistor to get this voltage, because what goes in must come out. So if there's a drop here, we subtract that, we have what's out. So we get the voltage across the resistor, and then we subtract it from what we have in to get V2. That's the basics of a resistor in series and Ohm's law and how it relates to it. Later on, I will describe this in more detail, and it will be more understanding with parallel and series circuits. But there's also other components that do different things. We have resistance, which is this real thing that does real power. It takes away power. But then we have things like capacitors and inductors, which do stuff a little differently. And we'll talk about that later, but just know that there's not just resistance. We have stuff called reactance, and that combined with resistance can get you impedance. Well, that combined with a imaginary term can get you impedance. So we'll describe this in more detail later on, but hopefully this gives you a little bit better of an idea of what resistance is and how we kind of use it in math and where to start in electrical engineering, math in general. For my first example, we have a 3 amp current source. So you can have voltage sources and current sources, and they do the same thing. If they're DC, they'll do the same thing. If they're AC, they'll do the same thing. Like, you can't have 3 amp current source in AC be the same thing as a 3 amp current source in DC. That's not the same. But a 3 amp current source in DC is the same as a certain amount of voltage in DC. So it's the same thing as saying this is a voltage source, is what I'm trying to say. We have a current source of 3 amps, which will go through a 2 ohm resistor and a 3 ohm resistor in series. What we need to do here is we need to find what the voltage is. So the voltage that is being made here. The way we can find the voltage from the source by having the current is by using Ohm's law. So voltage is equal to I times R. Well, we have 2 resistances in series, so we can just use this equation. We can first do a simplification, though. We can combine these two because they're in series and just say this is 5 ohms, because resistors in series add together. Parallel, it's a little more complicated. But so this is the same thing as saying 3 times 2. So V total would be equal to the amperage times the resistance plus this. The amperage stays the same in series. There's a voltage drop across this and a voltage drop across this, but it stays the same. So then we'd have 3 times 2, or 3 times 3. So we'd have 2 different voltage drops because there's 2 different resistors. However, this is the same thing as saying they're together as a 5 ohm resistor. So let's compare this. Let's just say that it's 3 times 5 now, just to make this a little more understanding. I haven't done any of this, I just know the math works. So I just randomly put these numbers down too. This should equal out. So for here, for V total, we're going to have 6 plus 9, which is equal to 15 volts. 15 volts total here. So it's you could say this is also a positive negative 15 volt source. So you could say there's a potential difference between here and here of 15 volts. It's the same from here in this entire region. There's a difference in voltage from here and here though. So hopefully that makes a little bit more sense. And then here is also 15 volts, which makes sense because the resistances added together is the same thing in series. So 15 volts, two different ways of getting the same answer, but we know that this 3 amp current source also supplies 15 volts. The thing is though, when we combine these, we can't see the voltage drop across each of these resistors, but while they're like this, we can very easily. You know, it was just, this is 6. So 6 volts dropped across this resistor, and then 9 volts dropped across that resistor. Hopefully that makes a little bit of sense.